Okay, I've got your attention, but there's something else that needs your attention. The real-world power consumption of the CPUs, Ryzen 7000 versus Intel's 13th gen. As a creator, I was very concerned and alarmed by the Intel's 13th gen maximum power consumption of 300 and plus watts consumed when utilized. And as I was testing the real-world power efficiency in a real-world workload, I found some very mind-blowing results. And neither AMD nor Intel is actually telling you the full story, and it's not what you think. In fact, I think it's the very opposite that you might think, and I'm very surprised that nobody is really talking about it. Even the bigger YouTubers are kind of telling you half of the story. What we need to talk about is real-world workflow power efficiency. Let me explain.
Looking for a cheap way to license your Windows? Check out Whokeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out whokeys.com in the video description below.
In a moment you're going to see some results, but first I need to explain what these results mean and what these numbers actually tell you. First of all, power consumption and efficiency at 100% utilization. So you might have seen some footage of Intel consuming 300 plus watts at 100% utilization and the Ryzen 9 7950X like 250 watts plus, and you think, flipping heck, these processors use a lot of power. Well, that is like the maximum speed. And if I can give you an example of that, that would be like measuring the fuel consumption of the car at the top speed of the car. Let's say the car runs, 200 miles an hour, and let's measure the power or, fuel economy there, which would really be mental, and it doesn't make a lot of sense, and it doesn't tell you the full story. If we're really talking about power efficiency and performance per watt, we need to look at the workflow. And as a creator, that's who I am and that's who I'm talking to mainly. Most of the time, it's not 100% utilized. That's the point here. And when we're looking at the real world, like workflow as a creator, you have mixed usages of the, processor. And then when we're looking at the average, utilization, it's probably below 50%. I dare you to use Hardware Info 60 More or Hardware Monitor. Just put that program on during your normal workday, and just in the end of the day, let's see what's your average utilization of the CPU. I'd be very interested to know your results. Secondly, even though that maximum wattage drawn at 100% utilization is not helpful knowing the performance per watt, what it is very helpful at knowing is what type of cooling you need. Because when we see 250 plus watts pulled, we know that we can't get away with like a medium tier air cooling. But that's when we're not applying the Intel's limit, because a lot of the motherboards out of the box come with Intel's limits exceeded, or letting the motherboard pull as much power out to get as good of a multi-core performance as possible. Asus, for example, is calling it at multi-core enhancement. But Intel is actually saying that this processor can use 253 watts at PL2 limit. So basically, unless you are forcing all of Intel's limits, you do need a very high-end cooler for the 13900K and then the 7950X, because they pull a lot of power from the socket and can run very hot. Now, if you do apply Intel's limits, you can get away with less of a cooler, and even high-end air coolers will be fine, and you will lose a little bit of multi-core performance, and then the processor will be even more power efficient. But in our case, what I tested here is what most people would do is you get the CPU, you get the motherboard, you pop it in, you maybe enable XMP and the iGPU, you don't mess around with any of the settings, see how it is at default, and then measure the power efficiency. So in our case, in our Asus board, this 13900K pulls over 300 watts when 100% utilized. Number 3, and one of the most mind-blowing, kind of even accidental discoveries that I did with the Intel processors, is that they idle at very low wattages. They can go below 10 watts at idle, probably due to the efficiency cores in the hybrid architecture of the CPUs. The efficiency cores can run very efficiently in the background or when you're doing minimal tasks, and then the performance cores just kind of boost in and use the power, when they're needed. Whereas on the AMD, which almost seems like a bit of a problem in AMD is that AMD idles at 5 times or even more, sometimes higher wattages. So in a real-world workflow where we've got mixed results of CPU usage, it's very interesting to see how does it perform then, because max power consumption of AMD is much lower than Intel's, but then the minimum or low power consumption of, minimal tasks or very low CPU usage is much lower on Intel. Which one is the real performance per watt winner? Number 4, which programs did I test then? I tested Lightroom Classic because that is a mixed workflow of multi-core and single core. There's active and passive scores. So when you're working on your photos, that's very lightly threaded tasks. So basically you use the single core performance of your CPUs, and you need very fast cores when you're, working with the faders and, flicking between photos and so on. But then also Lightroom Classic uses a lot of photo export, which is multi-core, and then photo merging and applying effects to a lot of the photos. That can also be multi-core usage. So it's kind of 50-50 workflow that I tested here. Then I tested Photoshop, which is mostly single-threaded, but also some of it is multi-threaded. It can use multi-threads, but it's not as efficient in multi-cores than Lightroom Classic. Photoshop really likes to use single-thread things. And then also I tested Premiere Pro, which is really a mixed workflow of things, because timeline performance often uses like 100% of the CPU usage. And then we've got a lot of things there working in there, and there's a little bit of GPU in the mix as well. So why did I choose these things? Because these are very CPU focused tasks, and to really kind of focus on these tasks, I could have taken something like Resolve, for example, but Resolve uses a lot of GPU, and then we're adding another thing in the mix which doesn't really tell us the full story of the CPU efficiency performance per watt. And I didn't also use a Blender, for example, which is like almost 100% utilization, which you can see a lot of big YouTubers use Blender, because that will only tell us a part of a story, because most people aren't using these CPUs just for Blender rendering, and when they do, they most likely go for a Threadripper system or like much higher system, or in fact, I think most people move away from really rendering on a CPU to a GPU rendering, which is many times more powerful and faster, as you can see from my recent poll. And also, I'm not testing gaming here because we're not focused on gaming in this channel, and if you do want to see that, you probably have to request this from your favorite gamers channels. I'm sure there's plenty out there. And fifth, finally, how did the testing work? Basically, I was running a Testbench benchmark for Lightroom Classic, Photoshop, and Premiere Pro, because that is repeated workflow that I can do on every single system again and again and again, and it will be exactly the same, and it will give it exactly the same task to do for the CPUs or for the computer system. So it's very easily repeatable. And these Testbench benchmarks really test different aspects of the program and the CPU. Single core, multi-core, what you would do as a creator, it mimics the workflow kind of the best what I can repeatedly do over and over again. As soon as the test started, I pressed 0 on the hardware info 64, and I measured the whole power consumption during that workflow, as you can see in some of the B-roll on the screen. The OBS was recording in the background as well, the screen record, which also kind of adds to the creative workflow, because most of the time as a creator, you have something else working in the background. And it also tests the CPU multi-core multitasking ability. How well does it do, or how well does it use power when other things are working in the background, just to give the CPU another thing to do. At the same time, we're not taking a lot of performance away from the CPU because it uses the NVENC encoder to actually record the screen from the GPU. Before you write your angry comments about hardware versus software measuring of the power consumption, I want to share the results first, and then I'll have a comment about that. If you do want to see the testing setup for both of these systems, then I'll leave that in the description below as well. Now you can see these results on the screen. So I do want to kind of explain some of these numbers that you see here, just so you're familiar what we're seeing. On the first column, we can see the score of the test. So how fast or how much did it score on the test during that benchmark. Then we can see minimum and maximum power consumption during that load. We can see how much was the maximum power draw and the minimum power draw. And then we can see the average power draw during that test, which is probably most important factor here. Then we have performance per watt calculation, which basically means we're gonna divide the score by the average power consumption so we know how much is the performance per watt during that kind of load. Then I'm also measuring the time, how long it took to actually complete the task. And then we see the energy consumed by kilowatt hours per year state. So basically what we did is we're going to take the time it took and the wattage it pulled average during that time, and we're going to calculate how much would it cost if we did exactly that same workflow 8 hours a day, 5 days a week, 20 hours a month, and then 12 months a year. How much power did we use? And that's measured in kilowatt hours per year. And also the last column is the energy consumption of the year. But basically this you can calculate by taking the energy consumed per year. And if you take that times the average, electricity usage per kilowatt hour in your country, then you can measure the actual, electricity cost of the year, which in our case is in pounds because I'm here in the UK, and that's what we've calculated out here. I did do the test of the Ryzen 7000, 13th gen and 12th gen CPUs, and the top of the chart here is the 12600K at 27.5. So it's quite a big jump actually over the 13600K, which is much more powerful, but performance per watt isn't as good in Premiere Pro workflow here. So this is Premiere Pro that we're looking at here. We can see, interestingly, that all of Intel CPUs here are on top of the charts. And then comes all of AMD CPUs, and then they go backwards. The Ryzen 5 is the most efficient, in terms of performance per watt, then Ryzen 7, and then the Ryzen 9s exactly backwards. But interestingly, if we look at something like the 13900K and then 7950X, then the 13900K is quite a bit more in terms of performance per watt. But that's due to the minimum power consumption. As you can see, the 13900K, the minimum power consumption during that task was 9.89 watts. But if you look at the 7950X, the minimum power consumption was 54.5 watts. That really makes a big difference there. So in Premiere Pro, the Ryzen CPUs are much less power efficient in terms of power per watt. Even the Intel 12900KS, which is the least power efficient, is quite a bit ahead over the Ryzen 7600X. But here, that's not complete fair comparison between Intel and AMD, just because Intel has iGPU inside and gives a lot of performance in the timeline. It has a massive performance overload over the AMD side. So it has a bit of a, benefit in there, getting much higher points, as you can see here. Even the 12600K gets higher points than the 7950X of the overall score. So that's not telling us the full picture. Moving on to Photoshop, we see slightly different picture. The 12600K and 13600K are on top of the charts again with the performance per watt calculation. They are the best performing CPUs there. But then now we can see that Ryzen CPUs, because of the single core performance, actually get quite a good scores as well. And the Ryzen 7600X is actually better in terms of performance per watt than the 13900K. Not much, but it still is better. And the 12900KS here is not very efficient really. And then the slides further down in the charts, but then you can see that the Ryzen 7900X and 7950X are still on the bottom of the charts, roughly consuming or getting the same performance per watt. And interestingly, there is a bit of a jump between the best of Ryzen, which here is 7600X, and the 13700K. There is a bit of a gap over there, about 3 points per watt, which is quite a bit difference compared to the rest of the things. And then the i5's 12600K and 13600K have a big of a gap between the mid-tier CPUs as well. And then lastly, Lightroom Classic. Here, the multi-core and single core kind of combined workflow, we can see similar results, that the Intel CPUs are on top of the charts. Then there's a big gap between the 7600X and 13900K. The 13900K is actually more efficient than the Ryzen 7600X by quite a bit. There's a big gap between them. And the 12600K and the 13600K here is actually much higher. As you can see, the 13600K has quite a big gap between the 12600K as well, just because of the single core performance, and more cores will be performing much better. But interestingly, the Ryzen CPUs again are on the bottom of the charts, and that's mostly due because of the minimum power consumption. As you can see, Intel CPUs consume like single digits, where Ryzen CPUs consume double digits, and we're not talking about 20 watts, they're about 5 times more than the Intel CPUs, which just overall equates to more performance per watt for the Intel CPUs, which is very interesting. And now if you look at the cost of the electricity between, let's say, the Intel system and Ryzen system, let's take the top of the chart, like the worst case for both of them, which would be the 7950X and 13900K. If we move back to Premiere Pro for a second, you can see that the 7950X would use about 21 pounds worth of electricity a year, whereas the 13900K would use 16 pounds and 71. So there's only about 5 quid difference over the year. Now you can calculate your usage in your country with the electricity prices, but it's not that big of a difference. So people who think that, oh, you're really gonna make up for AMD systems because they're gonna consume much less energy over time, it's not true that AMD will be power efficient, first of all, because they aren't. And then secondly, there's not that big of a difference between them two. If there's about 50 quid difference between the price points, that takes about 10 years for the price to actually get equal. So the price difference really doesn't matter here as much. Then we're looking at the Photoshop here between the i9 and then the Ryzen 9. You can see that the i9 uses 25 pounds worth of electricity, and the Ryzen 9 uses about 7 pounds more. Again, we can see 8 pounds a year electricity difference. That's not that big of a difference at all. And in Lightroom Classic here, we can see that the i9 consumes 42 pounds of electricity, whereas the Ryzen 9 would consume about 61 pounds of electricity. Here that's a big of a difference, which is about 20 pounds or so. But here's the thing, these tasks are mostly when the CPU is used in these benchmarks. But if your workflow is more idle, or less towards the idle CPUs, then the Intel CPUs creep even more ahead and even more ahead. Because over the year in time, I think most of the time if you're working on a system, like even in video editing or photo editing, you're using mostly single core performance. You're gonna be working on cuts, and you may be adjusting the color grade, moving them up and down. That's mostly single core performance. Most of the time you're not exporting the video, and even when you're exporting, even then it's not 100% utilized. You might be seeing somewhere between 30 to 75% utilized because you still use a lot of GPU and so on. The real world kind of yearly difference, price difference, would be actually much bigger when we're using it in real world. But this is just the best representation I can do with repetitive tasks. And now I want to talk about the hardware versus software kind of testing comparison, because a lot of people might be saying that, look, your testing is not accurate because you're measuring software rather than hardware. You should be measuring the power draw from the EPS plugs of the CPU socket. And I would actually agree with you. I understand why you would think that, and I think you would get much more accurate test results when doing it that way. But first of all, I don't have that testing equipment and it can cost a lot. Secondly, when we're testing it from the EPS plug, we're actually adding things in the equation that affect the power efficiency, which would be, for example, the motherboard. The motherboard power delivery, how efficient is that? Other things that might use the power and so on. So it's not the CPU usage alone. And I don't know a tool how I can measure the power efficiency over time in average through the EPS plugs. I've looked online. I know that there's some tools there. If you know a tool that would be good and would work like that, where you can measure the average over time, then I'd love to get it and let me know in the comment section below. I know the Bauer and the Thermal Grizzly is working on the GPU version of something like that, but I don't know if there's anything for the CPU version of that. What I did manage to do thirdly is use just simple power, wattage meters that you can get for like 10 quid from Amazon or something like that. Plug both of the systems in and then measure the Lightroom Classic, test one row and then see if my testing results are really, really inaccurate or out of place, or do they line up there? Now I understand that when we did software, we might have a bit of a less coefficient kind of measurement inside the equation. So there would be inefficiency that's in the equation when we're measuring in software. But if we take that out, we should be still getting the same results, just the numbers are slightly different, if that makes sense. But the measurements would be the same because we're removing the same kind of part of the equation from both sides of the equations, which just means that the number in the end would be different, but we'd still see the difference between the two systems, which kind of makes sense here, or what we're looking for. But I did measure it, and as you can see some of the B-roll, I measured the watt meters from the wall, and we can see that the i9 13900K used 0.055 kilowatt hours during that time and scoring 1917 points. And then the 7950X used 0.67 kilowatt hours, which is 67 watt hours, and scored 1820 points. And if we calculate the average, performance per watt in this case, or performance per watt hours used of electricity, then we can see that the Intel used 34.8 and the AMD Ryzen used 27.16. Now I do want to mention that if you check out the Testbench setup in the description below, you'll see that the AMD system actually has a much better power supply, much more efficient power supply at 80 plus platinum rating rather than 80 plus gold rating on the Intel system, which means that the AMD has even bigger of an edge there. So if we did use the same power supplies on both systems, the gap would be again slightly bigger, favoring Intel. But because I didn't want to make another test setup and mess around with the power supplies again, I just wanted to see if I plug these in, what would the results be, and here they are. So what are the takeaways from this testing results then? Now, after weeks and weeks of doing the testing, measuring them, gathering the data, I can see that actually the real kind of performance per watt is much better at Intel systems. And if you're a creator, then Intel system gives you better performance per watt at the average rating, unless you're doing Blender render, then yeah, AMD. But I don't think many creators do that. And as I explained earlier on in the video, most likely your CPU is not 100% utilized. Secondly, the real money saving difference between these CPUs is not that big of a deal, and it really depends on your workflow. And I'd like to say that Intel is still a better pick there, because most likely your system's going to be more idle than my benchmark results here, because I was calculating the electricity cost if I ran this benchmark back to back, like throughout the year. But most likely that's not what you are doing, and your consumption would be much less, which means that the idle power consumption would be much less on Intel, which means it would cost less on Intel, but it would actually cost more on AMD because of the idle power consumption of the AMD would be higher. As a creator and as a professional, if you're doing this for work, I don't think you're going to have to worry about these anyway, because as you can see, it's not that big of a deal. But if you're asking me which is more power efficient, then Intel is the one. People who do say that AMD is more power efficient, it's not really true, as you can see from these test results. Now, I'm not talking about in every case and scenario, but I think for most people, that's not the truth. But if you are looking to build yourself best bang for buck creator PC, then check out the build guide in the description below, where you can find the different budgets of creator PCs. Pick the one that's closest to your budget, configure it to your needs. In the video, I'll have upgrades and downgrades and everything. There's build guides, everything in there, so you can build the best system for your money as a creator. And I'd love to know what you think in the comment section below about this topic. Any comments, I'll meet you down there. Thanks guys for watching, and I'll see you next time. Bye bye.